Hello and welcome to the latest episode of Feeding the Curious Mind. My name's John Pullen and I'm a writer of fiction and non-fiction books. We're going to talk about one of the fundamental questions of the universe, and that is, how did the universe begin? Well, I'll tell you now that I'm not going to give you an absolute definite answer, but what we will discuss is what we believe to be true at this time. Now, most of you will say, oh, well, it started with the Big Bang. Well, yes, that's part of it. And in fact, after a number of years, most scientists think that the Big Bang, as explained, still plays a strong part in the start of the universe. Now, one of the things we can do today is to look at very, very distant galaxies. And due to things like the red shift, which I won't go into at this point, we can tell that the furthest galaxies away from us are retreating even further away. And not only are they retreating, they are accelerating. Some of them close to the speed of light. So, putting our logical hats on for a moment, if it's expanding now and accelerating away from us, there was a time before when the universe had to have been smaller. And if we keep thinking about this, the universe will get smaller and smaller and smaller. So that perhaps about 13.7 billion years ago, although some scientists think it's about 15 billion years ago, the universe would have been microscopically small. In fact, so small it would have been smaller than a single atom. This would be known as a singularity. Where the singularity came from, we can't really answer that. But we do know today that we have observed some subatomic particles seemingly coming into existence and then popping out of existence. So there seems to be perhaps a way for this singularity to suddenly appear. But the big question you may be asking now is that if all the mass in the universe, all the billions and billions of galaxies, were compressed into a singularity, something smaller than a single atom, how on earth is that possible? Well, we can thank our old friend Einstein for helping us out here. One of the most famous equations, I suppose, in history is one of his, and it's E equals mc squared. Basically what this means is that energy and mass are connected, interchangeable. And if we look at the equation, we can tell that a very small amount of mass can equate to a huge amount of energy. So if we look, E equals energy, and M is mass, but it is then multiplied by the square of the speed of light. And if we think about the speed of light as being something like about 186,000 miles a second, if we start multiplying that by itself and then multiply the mass that we've got, we can see that the energy obtained is huge. So we have a singularity, and all the mass and everything else that we have in the universe today is in that singularity, but it is in the form of energy, not mass, because the two are interconnected and we are looking at the singularity full of energy. Now, after a very, very short time, and when we talk about short time here, we are talking about trillionths of a second, the singularity starts to expand. And in its very, very early stage, we have a material called a form of plasma. There are no atoms, there are no subatomic particles, just this plasma. After another very short time, I believe we are looking at things like 1 second divided by 10 with 35 zeros after it. So divide that number into 1 second and we have the start of what is called inflation. Inflation is where suddenly that singularity expands. It inflates at a tremendous speed. Literally over fractions of a second, it becomes huge. And to do this, it needs to have exceeded the speed of light. And now you're going to tell me that, well, Einstein again says, hey, you can't travel faster than light. True. You can't travel faster than light through normal space. But this inflation, this expansion of energy wasn't taking place in normal space because it didn't exist. It hadn't reached it. It would only form real space once expansion had finished, further down the evolutionary ladder. So we have this expansion, and then we have the start of subatomic particles being formed. The temperature is huge, but as it starts to cool down, as it expands, therefore we get more and more subatomic particles, which then start to collect together. Hydrogen, helium, the simplest elements in the universe, begin to be formed. So, although, well, let's put it this way. There's something else which at this time is another bit of a mystery to us. And that is that we do know that both matter, which we're fully aware of at the present time, and antimatter were created in equal amounts at the start of the universe. And as most science fiction people know, when matter meets antimatter, you have self-destruction on both sides. So if there is an equal amount of matter and antimatter, why on earth is there anything here at all? It should all have destroyed itself. Well, it's believed that there was a slight, and I mean a very slight, difference in the amounts, and matter won. And the matter that won is everything we can see about us today. So we know that the universe probably started about 13.7 billion years ago. It's still expanding. We don't know how it might end, but that's another story. But let's just wait and see. But it might take us another 13.7 billion years to find the answer.